Good morning, ladies and gentlemen. I regret that I can't be with you today, but I wanted to show you that the experiment that we would have done if we had been together today, we're going to look at equilibrium processes. And to represent an equilibrium process, I've got a couple of graduated cylinders here filled with an easily viewed green liquid. It's just water with food coloring, no big deal. And what we're going to do is we're going to move some of the liquid back and forth between the two containers and see what it takes to stabilize the situation. Now, the first thing we need to do is figure out how much we've got in each. So I'm going to take each one and I'm going to read it. And remember, read at the bottom of the meniscus. And we'll call this one on my left, your right, cylinder A. So cylinder A, I read, it has a volume of 65.0 milliliters. So I have here a document that I'm keeping track of. So I'm going to write 65 milliliters. And this other one I'm going to look at, I'm going to read that, and it is also 65.0 milliliters, almost as if I had set it up that way. Okay. Excellent. So two cylinders, 65 milliliters in each. Now, I'm going to start transferring liquid between the two, and to do that, I'm going to use two straws. Okay, so I have the big fat red straw, I have the skinny little clear straw. So we'll establish some operating conventions right now. First of all, we're going to put the straw as far in as it will go and still allow me to hold on to the top. Okay, so that's the first convention. Secondly, with the skinny straw, I'm always going to take from cylinder A and transfer to cylinder B. With the wider straw, I'm always going to take from cylinder B, transfer to cylinder A. So let's do that. Okay, pull them out, switch them, hopefully with minimal loss of liquid, which of course doesn't ever actually happen. But got those. Now, let's read the volumes. So cylinder A now has a volume of 66 milliliters, and cylinder B has a volume of 64 milliliters. All right, so once again, on our chart here, so cylinder A is now 66 milliliters, and cylinder B 64 milliliters. And now we're going to do it again. Again, dip the straws in as far as they'll reach. Probably put them closer together. Pull them out, carefully switch, empty, straws down. Okay. Cylinder B is now up at 68.5 milliliters, and cylinder B is down to 60. So let's write that 68.5 milliliters, 60 milliliters. Okay, let's do it again. How many times are we going to do this? Well, I'm going to do it until the values don't change. That's the point. Okay, so once again, again with practice, hopefully this gets easier. Okay, so cylinder A is now 70 milliliters. Cylinder B is now 58.5. So again, record our data. 70 milliliters, 58.5 milliliters. Okay, so far so good. Do it once again. Get as far down as they'll go. Up, switch, release. Now you can see the transfer here is not perfect. I can tell that. You can't see it, but I can see several drops of liquid on the table here. experimentally, that's what happens. Okay, so cylinder A, I'm now looking at 71.5. Cylinder B, I'm now looking at 56. So 71.5 milliliters, 56.0 milliliters. Okay, interesting. Nominally interesting. Okay, let's try this again. And like I said, we'll keep doing this until, let's try that again, didn't get a great seal on that. Plus side, I think I am getting a little better at the transitions. I suppose we'll see. Okay, cylinder A, we are up to 71.3, 73.5, and 55. Okay, 73.5, 55. Okay. And again, I'm just reading these to about the nearest half milliliter is all. With these plastic graduated cylinders, it's hard to really read precisely beyond that. Okay, ooh, best transfer yet, I think. Okay, let's see what we have. Looks like 75 even and 50, 1, 2, 3 even. 75 and 53. Okay. And again, admittedly, this is not the most exciting thing you might do in a chemistry lab. Let's try that again. Switch, release. Okay. So 76 and 52. 76 milliliters, 52 milliliters. All right. Now on the data table that you saw for this, you saw that there's place for 10 entries. It might take longer than that. It might take more. If it takes more, then we'll make more places. Okay. This one is now 78, and this one is now 50. Interesting. 78 milliliters and 50 milliliters. Okay. If you're keeping score, that means that we've at this point lost about 2 milliliters of stuff in terms of drops and that sort of thing. It happens. What are you going to do? Okay, switch, release. Okay. Once again, 78. And looks like we got 50. Okay. 78 milliliters, 50 milliliters. That's our 10th trial. Let's do one more just to make sure that we have consistent results. Okay. All right, so out, switch, release. Uh, 78 and 50, good enough. Okay. All right, so here's our data table. Hopefully that is legible. If not, I will go ahead and make an actual table of this and post it someplace where you can find it. Okay, that's part one. So for part two, which now we have a second data table we can fill out, we're going to change one of the conditions. What we're going to do is we're going to take out cylinder B and replace it with this one. This is our new cylinder B, and this one has got 80 milliliters of fluid in it as well. This I did not really plan. I didn't really plan for both of them to have 80, but here we are. Okay, and of course, always write down your numbers, because if you don't write down your numbers, you're not really doing science, you're just fooling around. Not that there's anything wrong with that, but in a science classroom context, you ought to have some results. Okay, so we're going to start over. This is trial 2, and this is the first swap. Okay, so our initial values are 80 in each. After one switch, cylinder 1 now has 82.5, and cylinder 2 has 77.5. Okay, 82.5 milliliters, 77.5 milliliters. Okay, good. Oh, that would have been problematical. Okay, so pull, switch, release. I can see one drop running down the outside of cylinder A, so I know we've lost a little bit of liquid. It is what it is. Okay, so cylinder A, I now see 86 milliliters, and cylinder B, I now see 74. Okay, so 86 milliliters, 74.0 milliliters. All right, let's try this again. Come together. All right, pull, switch, release. Okay, cylinder A, we are now at 87.5. Cylinder B, we are now at 72. Okay, 87.5 milliliters, 72.0 milliliters. Okay, once more. Switch, release. Okay. We are now at 89.5 and 70. Okay. 89.5 and 70 milliliters. Okay. Our next swap. Again. You'll notice I'm trying to keep the same conditions every time I swap, dip them the same depth, that sort of thing. Had I access to better equipment, what I would do is I would have used shorter cylinders like this tall. That way the straw would go all the way to the bottom. That would be more consistent. But when you don't have better equipment, you just have to alter your technique. So cylinder A, I now see 91.5 and 67.5. 91.5 and what did I say here? 67.5. Okay. And we're almost 15 minutes in at this point. You're probably thinking, wow, 15 minutes of my life I will never get back. Yeah, it is what it is. Okay. So we have now 90 93 and 66. 93 milliliters, 66 milliliters. Okay, next. All right, 94.5, 64. Okay. Come on. All right. Okay. Whoa, interesting. 96.5 and 62.5. 96.5, 60. Okay. 96.5, 62.5. All right. Let's try it again. It's like 97 and 61. All right, that was number 10. So let's do number 11. And 97 and 61. Good enough. We'll call it a day. Okay, once again, here is your data table. And if you can't read this, let me know and I'll post the two data tables. I'll type them up and post them someplace where you can go, but hopefully this is legible enough that you can see it. So this is data from trial 2. This once again is the data from trial 1. You now have the numbers you need. If you'll go ahead and use the sheet that I gave you, you can complete the assignments, that sort of thing. Complete the calculations and submit your results. Okay, it's good to talk to you again. I wish I could be with you in person, but of course present circumstances don't allow. If I don't talk to you between now and then, we'll do another thing like this next time. Goodbye.